right, here we are in section 2 now. Section 1, remember we were multiplying monomials, so now we need to divide monomials. And all this is leading up to being able to combine polynomials, meaning many nomials, hence the poly. But before we get there, we need to know what to do with all these single nomials. So, just like with multiplication, we had 3 different scenarios. In division, we also have 3 scenarios. When we're trying to divide bases, you subtract the exponents. That's actually a typo there. The blank should be subtract, and I messed that up. Didn't notice it till after I passed the papers out to you, so we can fill in the blank with u. So we're going to subtract exponents. So just like with multiplication, combine the ones that are the same. So x to the 5th over x, and I can write my y's off to the right, y to the 8th over y to the 3rd. Now I'm dividing my bases, so I'm going to subtract my exponents. This becomes x to the 4th because I do 5 minus 1, and I do 8 minus 3 to get y to the 5th. And that's all it is. All right? Easy enough? Pick your like variables out, the ones that are the same, subtract them. Okay? The second scenario that we have, letter B. To take a fraction to a power, we want to distribute the exponent to the top and the bottom. Okay, so this 4 goes to the top and to the bottom. So we'll have 2x squared raised to the 4th power. I hope that looks familiar. And 3 raised to the 4th power. Here up top, it should look familiar from section 1, where we have a power to a power, so I have to distribute that 4 again to become 2 to the 4th x to the 8th over 3 to the 4th. Now I need to simplify. 2 to the 4th becomes 16. Ooh, that'd be bad if I'd said 8. And the bottom becomes 81, x to the 8th. If I follow my 3 rules of simplified monomials, I see that there's only one variable, there's no parentheses, and then 16 over 81 does not simplify. Okay? So we know that that's the final answer. And the last thing we have for division rules is anything to the power of 0 is 1. So x to the 0 power is 1. All of this information here inside the parentheses is taken to the 0 power, so it's 1. Nothing to do at all. As soon as you see something to the power of 0, you know it's 1. Easy enough. Okay. Moving on. Now we need to talk about negative exponents. Okay. In a negative exponent, you can have 2 different scenarios. The first one, case 1, is the negative exponent in the numerator. When that happens, I want to move the base, meaning the variable or the number that the exponent is with, the base and the exponent to the bottom. So it's just going to flip from top to bottom. Then I want to make the exponent positive. Okay? So when I look here in this example, this 3 is my negative exponent. So I'm going to take that to the bottom. And I'll have x to the 3rd, x to the 3rd, and y. Now I need to simplify. I see that I have 2 y's and 2 x's. That means I need to do some combining. Start with my x's. I see that they're multiplied, which means I add the exponents, which gives me x to the 6th. I look at my y's over here. I see that they're divided, so I subtract the exponents and make it y to the 3rd. Okay? There's no numerical fractions to simplify, so we're done. All right. The other scenario that we can have is a negative exponent in the denominator. And this should be fairly simple, make sense to us that if the exponent is in the denominator, it means we're going to move the base and the exponent to the top and make the exponent positive. Okay? So this time I have a y to the negative 4th in the bottom, which means that I move it to the top. So I'll have x to the 6th, that stays. I have y, that stays. Then I also have a y to the 4th. On the bottom, my x stays. Okay? Now again, I have to simplify, combine my x's and combine my y's. This time my x's are being divided, so that gives me x to the fifth. Okay? And up top, I have x or y's being multiplied, so that gives me y to the fifth. And there's my answer. Okay? Hope there's no questions so far. If not, feel free to write them down, ask them in class. Go back and re-watch anything you need to. One thing I do want to point out here is when I have this x to the sixth and x, okay, when I'm dividing, the way that I decide where my variable goes at the end, whether it goes on the top or on the bottom, is to look at where there's more x's. Okay, there's more x's on top, so my final answer is x to the fifth over 1, or just x to the fifth. You're always going to put where there's more. So, quick example here off to the side. If I had x over x to the fifth, that would mean I have 1 over x to the fourth, because there's 4 more x's on the bottom. Okay? So, make sure you pay attention to where there's more x's at. All right? Let's try a couple examples here together. First example, x to the third, y to the 0, x to the negative 7th. Okay? So we got a couple things going on here. I notice there's 2 x's that need to be combined. I have a y in the middle. I notice that this y has an exponent of 0. So that automatically becomes 1. So now I have x to the third, x to the negative 7th times 1. All right, don't need that. I notice I have a negative exponent. When I have a negative exponent, that means it has to go to the bottom. So I can rewrite this as x to the third over x to the 7th. Notice I don't have to write times 1 every time, because just like adding 0 times 1 doesn't change anything. So I don't need to write the times 1. Now I'm just playing where is there more. There's 3 x's on top. There's 7 x's on bottom. When I divide my bases, I subtract my exponents, and that tells me that there's 4 x's on the bottom. Okay? Use my simplifying rules. I notice that there's no parentheses, that x is only appearing once, and that there's no numerical fractions to simplify. So we're good. And the last example that we have here. Okay, when we have a big fraction like this, you really want to break it apart into each group. Variables the same, numbers the same, etc. That'll help keep things simplified. So I can start by doing 30 over 5. Those are my numbers that'll go together. Then I can look at my x's. X to the negative 2 over x. And then I can look at my y's. I have a y to the 14th, and I have a y to the negative 3rd. Now, breaking it apart, I can see exactly what needs to be done. Okay? If I'll put my big fraction down here, 30 over 5, I can see simplifies to 6 over 1. So I can write that down here as 6 over 1. My x's. I see a negative exponent, so I know that needs to go to the bottom, which means I'm going to have a 1 left up top, x, and x to the second. X times x to the second, we're multiplying bases, so I add exponents to get x to the third. And for my blue, my y's, a negative exponent means that has to go to the top. So I'll have y to the 14th, y to the third. And again, I'm multiplying bases, so I add exponents and get y to the 17th. Okay? I take a look. X is appearing once, y is appearing once. 6 over 1 has been simplified. There's no parentheses. So there's my final answer. Okay? I hope this all makes sense. We'll get plenty of practice with it in class. Make sure you get the homework done for that. And I'll see you back here next time with Chapter 7, Section 3, doing an introduction to polynomials. So good luck and take care. Bye.